Let's take a look at some cooling system tests. Just like any service, a proper visual inspection should be done first. Radiator and coolant hoses should be inspected for signs of age and deterioration. Looking for bulges on the hose near where they connect on the radiator or coolant fittings indicates age and possibility of a weakened hose. Hoses should be pliable and soft, not rock hard. Oftentimes, oil contamination can cause hoses to turn very gummy and super soft, and also indicates a failure. Condition of belts should also be inspected. There should not be too many cracks as indicated in service information on the grooved side of your serpentine belt. Also should not be shiny or glazed on the smooth side. Also need to check condition of the tensioners and pulleys on your cooling system belt. Remnants of dried coolant can also be seen on some vehicles if there is a leak. This vehicle has green coolant in it, and we can see right here we have indications of coolant leaking out and leaving a green haze near my thermostat housing. It also looks like it might have been spraying out and leaving droplets to dry off of my engine housing. We also see indications down here of an actual coolant drip. Coolant drips will often be found on vehicle components that don't get hot. Many times the coolant will get hot and steam off before it'll actually hit the ground. Sometimes you have to let the car sit overnight or for a long period of time to find actual wet coolant. Since this car is not equipped with air conditioning, I can see the front of my radiator right behind my grill. If it has air conditioning, you will see the condenser in front of this. Always inspect the radiator and condenser fins for blockages. Many times you will see blockages build up in between the radiator and the condenser, which is not immediately visible. Well-meaning customers sometimes put screens behind their grill to protect their condenser or radiator. Those can clog up much faster than radiators and can cause a airflow restriction. Always inspect radiator cooling fan blades and verify their operation. A cooling fan should have no trouble holding a shop towel against the radiator if there's proper airflow. Many modern vehicles have steel coolant tubes, either for passages outside of the engine or for heater hose connections. These can often rust and have O-ring fittings where they enter either the timing cover or other areas of the engine. Always inspect those for excessive corrosion or rust. When diagnosing coolant leaks, look for the highest point on the engine where you can locate the coolant residue. Fluorescent dye can also be added to the coolant to aid in diagnosis. Coolant leaks can often be hard to pinpoint for a couple of reasons. When a component fails and leaks, many times it comes out as a thin mist as the engine is warm, and then sprays that coolant residue all over the engine, making it harder to pinpoint. Other leaks slow down or stop as the engine gets warmer because the components are growing and swelling under the high heat conditions. A coolant pressure test can help diagnose these hard to find leaks on a cold engine. Your pressure test kit consists of a handheld pump with a hose and an adapter that goes onto your radiator or pressure cap. It also has a gauge that you pressurize the system to and watch for it to fall back down towards zero. If it falls back down towards zero, you have a leak in your cooling system. If it maintains the pressure that you set it at, then your cooling system does not have any leaks. This kit also has an adapter to go from your tool to your radiator cap. This checks the pressure holding capabilities of your radiator cap as well. Many kits have a multitude of adapters to go to different size radiator pressure caps, as most manufacturers have their own style and size. This test is going to aid us in finding cooling system leaks by simulating pressures on the cooling system that the engine would see during operating temperatures. During operating temperatures, often small leaks will turn to vapor before they hit the ground or before you can see them as a liquid. To start the test, remove the cap on a cool engine. We will look at the cap and see that it is rated at 16 pounds. We do not want to pressurize our cooling system higher than the rated level on the pressure cap. We now install our tool in place of the radiator cap. With our adapter in the released position, meaning not building pressure, we can install our radiator cap adapter. Once in place, turn the lever, and that will allow our tool to build pressure on our system. Since our cap rating was 16 pounds, we will build pressure on our system until we see 16 psi. We can now physically hear a leak in my cooling system. This vehicle had recently had an engine replacement with a used unit. After a quick tightening of the radiator hose clamps, the vehicle now holds pressure to its reading. For very small or hard to find leaks, you may need to pressurize the system and walk away for an hour or even more. If you do not see any liquid coolant leaks on the outside of the engine using this method, you may need to remove the spark plugs and check for an internal coolant leak, such as a breached head gasket, a cracked block, or cylinder head. To release the pressure on the tool, take the tabs and simply twist them slowly towards the released position. That will slowly release the pressure inside the cooling system. Once the pressure is released, simply remove the tool like you would a radiator cap. To test our pressure cap, we use our cap adapter, install it on our tool. We then simply thread our pressure cap onto our tool like we would our radiator. At this point, we should pressurize our tool to the level of our cap, in this case 16 pounds. What we should see is when we pressurize our cap, it should go close to the rating on our cap and then release. Inspecting the pressure cap is similar to inspecting the cooling system. Once we test our release point, we can also maintain pressure on the cap and watch to see if it drops over time. Once testing is complete, release the pressure on the cap, remove the cap from the tool and the adapter from the tool. In addition to pressure testing, always inspect radiator cap seals for damage or signs of age, such as this one compressed over time. A pressurized system is only as good as its weakest link. If you suspect an internal engine coolant leak, you can use a combustion leak test kit such as this. If coolant is getting into the combustion chamber, that means combustion gases are getting into the coolant. This specialized fluid changes color with the presence of combustion gases into the coolant. To use the combustion leak test kit, remove the radiator cap and siphon coolant out of the radiator or reservoir until it is 2 to 3 inches below the line. This prevents coolant from actually being sucked through the tool and the test fluid. To test for combustion gases, you will install your kit with the tapered cone into the radiator neck and fill the tool with combustion gas fluid. You should fill your tool with the fluid up to the first line. Always use new, fresh test fluid that is completely blue in color. Used fluid that has been previously tested could skew your results. Once you have the correct fluid in your tool, you can put the topper on it. This one uses manifold vacuum to draw gases through the fluid. Some tools have a squeeze bulb that you squeeze manually to draw air through the fluid. Once your tool is in place, start the vehicle's engine and let run for around 2 minutes unless the fluid turns yellow sooner. After your test is complete, remove your tool and inspect the color of your fluid. No change in the blue color indicates that there is no combustion gases entering the cooling system. I have taken the same sample of coolant test fluid and held it on my tailpipe of the vehicle. You can see that it has turned the test fluid from blue to a yellow. If you have any test fluid that is green, that indicates that there is some combustion gases getting into the coolant. It may be a smaller leak, but further inspection is needed.
That was a brief cooling system inspection overview. If you have any questions, please leave them in the comments. Also, don't forget to like and subscribe to the channel. Thanks for watching.